Good day everyone. In today's video, we are going to dive into Azure Databricks deployment and specifically focus on its default networking setup, public and private subnets. We will explore when and why Databricks uses these subnets, which components rely on them, and finally, how the control plane and the data plane utilizes these subnets. So stay tuned to learn about these important network configurations and how they impact your Databricks environments. First, let's start with a quick overview of Azure Databricks deployment. When you deploy an Azure Databricks workspace, it requires two subnets, one public subnet and one private subnet. These subnets are critical for the functioning of Databricks and they play distinct roles in managing network traffic, resource access, and security. So if you see here, we have the virtual network VNet -SI-ADB that is being used by this particular Azure Databricks service. Yeah, and this one we have deployed using VNet injection. Yeah, it's not a default deployment model. And now if you see here, we have the private subnet name. Let's go inside the virtual network that is being used by this Databricks. Yeah, and then if I go to the subnet here, yeah, so let's look at it. What we can see here is like we have two subnets. One is your private subnet and another one is your public subnet. So let's talk about what these subnets are used for. The public subnet in Databricks is designed for any component that requires direct access. This includes services that needs to communicate externally outside of your private network. For example, this public subnet is often used for driver nodes in Databricks clusters that needs to pull external packages, libraries, or connect to the external services. However, the use of a public subnet is tightly controlled by security groups, and traffic routing is configured to ensure that this access is secure. On the other hand, the private subnet is where the majority of your internal Databricks components reside, including the worker nodes that perform data processing. These components do not need direct internet access, but still need to communicate with other Azure services within your virtual network. Let's launch the workspace here. Let's click on the cluster. The cluster is currently down, yeah, but I just want to look at the worker and the driver machines here, yeah. So if you look at this, the worker node run in the private subnet for enhanced security, ensuring that your compute resources are isolated from the public internet. This is critical for data processing jobs where sensitive data needs to be protected. Now let's break down which components of Azure Databricks utilizes the public and private subnet. Driver nodes often run in public subnet. This is because they need to establish connections outside of the private networks for certain functions such as downloading libraries, communicating with external data sources, or interacting with services that aren't hosted in the same VNet. Worker nodes, as mentioned earlier, typically operate in the private subnet. The key reason for this is data security and performance. By keeping the worker nodes isolated from the internet, we reduce the attack surface, making the environment more secure. So we have several number of worker nodes, but you will have only one driver node. Yeah, the worker nodes has to communicate among themselves. Like for example, if you have more than one worker node, all these worker nodes are present in the private subnet, and each of these worker nodes basically have to communicate with one another for completing the processing. Additionally, your internal communications between Databricks components and other Azure services like Azure Data Lake, SQL Database, or Cosmos DB will be routed through this private subnet. Azure Databricks operates under a two-plane architecture, the control plane and then the data plane. The control plane manages the backend operations like cluster creation, notebook management, and metadata storage. It operates primarily outside your VNet and doesn't rely heavily on the private or public subnets within your VNet. However, when deploying clusters, the control plane interacts with the public subnet to manage things like control messages, API requests, and job scheduling. Since the control plane is managed by Databricks and is not part of your VNet, it only requires a small amount of interaction with the resources inside your VNet. The data plane is where all the actual data processing takes place. This is where the magic happens within your Databricks clusters. The data plane fully utilizes both the public and private subnets we discussed earlier. The worker nodes running in the private subnet or the heart of the data processing engine. Meanwhile, the driver nodes, which may reside in the public subnet, orchestrate tasks and communicate with the outside world when necessary. Let's take a deeper dive into how the control and data plane utilizes these subnets. As I mentioned, the control plane is mostly external to your Azure environment. It doesn't require extensive use of the private subnet. However, it can interact with the public subnet when it needs to push configurations or API calls to the cluster driver nodes which may reside there. The data plane, on the other hand, is where subnets comes into play. Worker nodes are placed in the private subnet for secure, high-performance internal communications. The driver node, which may need external communication, is placed in the public subnet but can still access resource within the VNet. By separating these components, Databricks ensures that your data processing is secure, performant, and isolated while still enabling critical external communications when necessary. One last point to consider is security. When working with Databricks and its subnets, it's important to understand how network security groups and routing configurations are set up. NSGs are used to control inbound and outbound traffic to and from your subnets. You can fine-tune these to allow only the traffic that's necessary for your workloads, reducing the risk of exposure to unwanted threats. By default, Databricks configures these rules, but for more advanced scenarios, you may customize them to fit your organization's specific security needs. And that wraps up today's video. We have covered the essential difference between the public and private subnets in Azure Databricks, how components like driver and worker node utilize them, and how the control and data plane fit into this architecture. If you found this video helpful, make sure to hit the like button and subscribe to stay updated with more Azure Databricks and cloud technology content. Drop your questions or thoughts in the comments below and I'll be happy to answer them. Thanks for watching JBS Wiki and I will see you in the next video. Jai Hind.